So as you heard a bit about, my name is Sean Barberie. I'm a graduate student, and I'm going to talk to you about flying robots and how drones are revolutionizing science in Alaska. I'm also going to have a few segues into other things that drones are used for and places where they found a home. So to start out, I actually added this slide at the very last minute. This question came to me over email. It was sent to me by one of the organizers, and they were trying to put together some advertisements for the talk. And I actually left it blank on the forum because I wasn't sure how to answer it. They asked me, what sparked your interest in unmanned aircraft? And when I thought about this, I actually didn't have a defining moment where something had happened or I had seen some use of unmanned aircraft that had sparked my interest. Because they're a fairly new technology. They're fairly young. And that's a point that I'm going to make a few times throughout this talk, is that there's a distinct difference between where unmanned aircraft are now, technology-wise, and what they're becoming, where they're going to be 5 or 10 years from now. And so one of the reasons that a lot of people like me get excited about unmanned aircraft, about drones, is because we are thinking more about what they're going to be in 5 or 10 years, and not necessarily what they are right this moment. And as a small illustration of this, I was thinking about it, and I realized that, say, in 5 or 10 years, we could have someone up on this stage giving a talk about drones who can say, my interest in drones was sparked when a package was first delivered to me by Amazon by a drone. You know, my Christmas presents arrived and flew in on a drone, and I was, decided to make that my research interest. Somebody will be able to say something like that. But I didn't grow up with drones, and no one in this room grew up with drones. But there are generations right now that are going to be growing up with drone technology in their lives. So I want to give a little example of that. This is kind of more of an artistic version of what can be done with drone technology. And that's an Arthur C. Clarke quote. Any sufficiently advanced technology is indistinguishable from magic. Everyone's probably heard that a few times. And the Wi-Fi is faster at home, it turns out, than in the Westmark. Well, while that loads, I'm going to tell you a little bit more about myself. I think I maybe hit that. Still good on sound? Everybody? Okay. So I'm not originally from Alaska. I've been up here for about 2 years, going on 2 years now. I'm originally from California. And you might guess that it's a little bit strange for someone from California to move to Alaska and start studying the Arctic. And you would guess right. It is very strange. I have never before lived in my place where there was snow on the ground at any time of year. And now here I am at this past week, we've had, what, minus 30, minus 40? So that's been a really interesting experience, but it's also given me an interesting opportunity to work with researchers here at UAF and explore some of the problems that are characteristic of the Arctic. And that doesn't seem to be loading. There we go. Okay, we're just going to go ahead with this then. So what's going to happen here is these lampshades here are actually going to lift off into the air, and each one of these is propelled by a drone, by a quad-rotor helicopter-like drone. So this little clip was not made with any CGI, any strings, any special effects. It's just a person and flying robots interacting. I think it's fortunate for me that people in Alaska are probably used to subpar internet connections. You guys have all had this experience before. So when it has this, I'm just going to talk, is what I'm going to do while it's loading. So each one of these little lampshades has a UAV inside of it. And as this video progresses, assuming it does progress, they will tilt at certain points, and you'll actually be able to see the little quadcopter UAV flying around inside of the lampshade. And so what I'm going to do is, as the lampshades tilt and you can see where the UAVs are, I'm going to point them out to you so you can kind of see this application. And the idea here is that you have some inventor, some old-timey inventor working late, and he starts to see strange things, and they can't necessarily be verified by the outside world. But this is also taking a lot longer than I expected. And one point that you're going to see here is the way he moves around, he actually causes the drones to move in different ways. That was actually not made using gesture control. You see, if he moves down, the drones move down. That was not made using gesture control. That was actually, the drones were pre-programmed to move in a certain way, and he's kind of dancing with the drones. But there are technologies going on right now. There are a number of research groups and applications where they have it so that based on what gestures you make, you can interact with the drones and cause them to act a different way in the room. So you can cause them to move around like you would interacting with a touch screen, just by moving your hand through the air. And I think I'm just going to actually go ahead and move on because this isn't working very well. Well. Yeah. Okay. Well, we'll go ahead and move on. And if we have time at the end, we'll just come back to this. So let's talk about what a UAV is. Let's talk about what a drone is. You heard a little bit from Bob McCoy about terminology, about calling it a drone, calling it an unmanned aircraft, the various things that people talk about. Well, one of the kind of silly examples is if we go back to 1905, this man named Julius Neubronner was a physician, and he invented what could arguably be called the first drones. He was a physician and a pigeon enthusiast, and he trained pigeons to deliver people their medicine in their homes. And this is actually an idea that will come back a little bit later in the talk. But at some point, while he was training these pigeons to carry people's medicine to them, he thought, well, what if I put a camera on those pigeons, and I have it automatically take photographs of what the pigeons see? And so he did that. And actually, in 1907, he patented the first ever pigeon camera. And you can see some of his photography here in the bottom left. They actually came out pretty good. So kind of tongue-in-cheek, but some people have called him the inventor of the first drone. A more modern drone is one that I actually have with me here tonight. It's called a Raven, and it fits into 2 briefcases. This is actually the most widely used aircraft, most widely used unmanned aircraft in the world right now. And it can be pretty quickly assembled, even in front of a fairly large audience. So, we've got the fuselage here. The nose cone can go on, and generally the nose cone will contain a camera or some sort of sensory device, depending on what you want to do. This pops right into the back here. And these ones are hand-launched, and I'll show you kind of how that looks in a minute. I'm not going to launch it, but because that would be a terrible idea. And I think this is actually probably a good example of a UAV to show, because it's so common, and also because it's fairly small. The UAVs have quite a range in size. There are some that people are experimenting with right now that are about the size of an insect, for looking in debris, earthquake wreckage, things like that for survivors. And then they range up to the size of more traditional aircraft, such as the Global Hawk is probably the biggest unmanned aircraft in the world right now. So there's the wings, about 4.5-foot wingspan. And they will slide on right here. And that's actually it. That's the Raven. So it's fairly light. Generally, you want to attach that a little bit better if you're actually going to launch it. And there's a battery that goes right here, so it's actually battery powered. And if after the talk anybody's so interested, I'll have this up here, and you can come up and touch it and feel it and see how heavy it is. It's pretty light, and generally what someone does to launch it is they start the motor. It has a real rear push-style propeller, and you simply run up and toss it like that, and it takes off from there. So I'll have this here after the talk. Please come take a look at it. And that's one of the unmanned aircraft. And I'm curious, actually, I was hoping we could play a little game here for this part. There are, as Bob McCoy pointed out, a lot of different names for unmanned aircraft, drones, things like that, and I was wondering what the audience has heard the most of. If we could just actually raise our hands for everyone who's heard unmanned aerial vehicle before, or UAV, right? This is a pretty common one. I'd be surprised if, well, yeah, that's a good number of people. This one's pretty prominent. And then Bob McCoy mentioned unmanned aircraft system, or UAS. Have many people heard that? See, that's maybe a third of the same number of people. It's a lot less common. It's especially a lot less common in the media. And then these two here actually have more specific meanings, but I was wondering if anyone's heard either remotely piloted vehicles or autonomous aircraft. Have either one of those, if you've heard it? Yeah, so pretty similar to unmanned aircraft system. It's pretty obscure, and those have specific meanings too. Obviously, something that's remotely piloted has someone using a tablet or sitting in a room controlling it, and autonomous is actually more interesting for future applications where the aircraft functions on its own without much need for us. And this one, I've actually only heard this once before, but I'm happy to hold up my hand for it. Unpiloted aerial vehicle. Has anyone heard that term? I see maybe 5 other people in the audience, and that one's pretty obscure also. And then how about drones? Who's heard drones before? Yeah, that's probably easily the most accessible. And there's this connotation in the media that drones is a negative word. Personally, I think it's something that we could easily appropriate and make it a positive word, simply because it's so catchy, it's short, it's easy to use. I don't know. People like to think of drones. They like to think of robots. I don't think of it as necessarily negative. But I was actually wondering, and I was hoping that if anything comes to mind among any of you, you would save it for the comments section and maybe make a comment and let us know what you think. I'm curious if anyone has any other ideas of what we could call unmanned aircraft. If we could come up with something else, something more positive, something maybe shorter than unmanned aerial systems. That's a lot of syllables to choke through. Just because there is a bit of a naming problem with these technologies. So let me know what you think. And we will move on. So one of the things I want to talk about is how a technology develops. So I've got the example up here of cell phone technology progressing over the past several decades. And I want to see how unmanned aircraft technology kind of fits into that schema. And so everyone here probably has a cell phone today. I've got a cell phone. And we can all agree that it's quite a bit different than what telephones were in the 1960s. If you told your friend that in the 1960s that you didn't answer his call because your telephone fell in the toilet, he would think that you were pretty crazy. Right? But nowadays, if someone tells you I didn't get your text because I dropped my phone in the toilet and my warranty doesn't cover it, you think, okay, yeah, that makes sense. That seems perfectly normal. But telephones in general, they haven't just gotten smaller, they've changed as a technology. They do things that people originally never expected them to do. Right now, I'm using my cell phone to actually time this talk, and I can see that I'm going a little bit fast, which is good to know. And even that's a pretty small application. One of the things that I was looking at about a week ago is during the missing Malaysia Airlines, there was a missing plane from Malaysia Airlines that had crashed somewhere and no one knew where it was. Does everyone remember this? This was just a few weeks ago. One of the things that came out of that is there's a website called TomNod where they took remote sensing data, they took images of the Earth from Earth-observing satellites, and they collected them and they posted them on this website of oceans and of scenes of the ocean where they think wreckage from this airplane crash may be. And then they had everybody just logging in with their phones, with their computers, and looking through these images, because it turns out the human visual cortex can detect features in images that computers can't detect yet. That's why you have to fill in a blurry series of numbers and letters whenever you're logging into anything. That little CAPTCHA is because that's what fools computers. We are still more advanced in picture recognition than computers are. And so what they had is they had this website so that you could actually scroll through and just say, I see airplane debris, I do not see airplane debris. And by that token, you could help this effort to find these missing planes. Now, when telephones were invented, before the 1960s, but for some reason I decided to start this on the 1960s, that was an absurd idea, that this communication device would someday be used to look for airplane debris in a place that you've never been, in another part of the world. That's a really obscure thing. And so what I'm curious about is how unmanned aircraft are eventually going to fit into this schema, because they're going to develop as a technology. So what I did is I placed here our carrier pigeons in the beginning to say, somewhere back there is the invention of unmanned aircraft, and then they progress. And my challenge to myself was to think, where are unmanned aircraft on this timeline today? Where are unmanned aircraft, where are drones in the equivalent of the phone evolution? I placed them about here, actually. The Nokia phones from the 90s on which you could play Snake and maybe Pong, which I thought was pretty amazing when I first got one. Because what they do is unmanned aircraft right now, they serve a purpose. They do various tasks, but they do them pretty simplistically, and they do them in a pretty limited way. Most of the tasks that you hear about unmanned aircraft and drones pursuing are tasks that are already performed by traditional aircraft. And that's kind of a limited thing. So if you think about right here, if you think about around 2005 when the first smartphone was invented, that's really when what we use phones for changed a great deal. We had phones that connected to the internet, we had phones where we connected with everybody we knew, and the app culture started developing. We started having different ways of communicating with people and different ways of communicating with technology. And in the future, because as I said, one of the things that I want to emphasize here is the difference between current drone technology and future drone technology, is in the future, one of the things that I think will be interesting is there will be, at some point, a development where we learn how to use unmanned aircraft in a way that we hadn't thought possible previously. And near the end of this talk, I'm going to give a few examples that I think maybe hint at what's happening in the future with drones. And then I'm going to give a few examples of this next step, which is the even more strange future, the things that we can't predict. I suppose the important point here is that with technology, with new technology, we as human beings are not very good at predicting what's going to happen next. If you are a sci-fi enthusiast, like I am, you watch a lot of sci-fi movies, read a lot of sci-fi books, grew up as kind of a nerdy kid, you know that a lot of the technology that's in sci-fi drastically misses the mark, that there are things that they don't anticipate. The internet being invented is something that we as a species did not anticipate. We didn't expect that it would connect us the way it does. I think that there will be a change in the way unmanned aircraft technology is used that actually improves all of our lives in a way that we actually can't anticipate yet. So, to talk briefly about current research, and yes, that is another YouTube video that we're going to try to load, beware. Let's look at a few of the current efforts we have going on. So this is actually a project undertaken by the University of Alaska Fairbanks and BP Oil to use a drone to inspect oil pipelines.
We're in Prudhoe Bay. We're using the Aryan Scout as a prototype, testing, looking at pipelines to see how it works in near proximity of pipelines. So this is a technology test and a little bit of a validation of the technologies that we're trying to use. The UAV can fly nearly ground level with the pipeline, something that we don't have to have a pilot for, and something that lets us fly at our opportune times, not just exactly the best weather times. This technology has the ability to carry an infrared camera and a visual camera, and gives us the ability to fly over the top of those lines, let us look down from the top, look from the far side, use infrared to see if we can find hot spots, and that gives us a way to look at the pipe that we can't normally see from the road. And if the technology proves out to be workable, it may be a technology we can use to enhance our operations in Prudhoe Bay.
This is the first time that we've flown this vehicle or anything for the pipeline. In general, flying in the Arctic is a challenge to begin with. There's actually lots of opportunities to use these vehicles in Alaska for the oil industry, pipeline inspection and potential leak detection, three-dimensional mapping, as well as change detection. You can fly it today and produce a 3D map, and then fly it again a week from now, and you can see how things have changed when it comes to not just the pipes, but also the rest of your infrastructure. It can make a difference on the way that you plan things.
Hopefully it will give us better speed in response. If we see it with the little Scout, we could actually stop right then and there, zoom in, get it photographed, and then we can send that off to our engineers and we can design the fix right from there.
And that's really what these things are all about. It has to do with making decisions, doing it efficiently, quickly. And in some instances, you get information that you would have difficulty getting it any other way. So it's quite an asset to have in the inventory.
This technology should make our operation safer. It allows us to fly from the ground. We don't have to put pilots in the air. We can fly in weather conditions that the pilots can't fly in. And then we can do it more frequently so we can look at our pipelines and improve the integrity of our operation.
This UAV type that you're seeing here is a quadcopter. That's the same thing that were in the lampshades in the video that was giving us such a hard time earlier. And I've heard them referred to as generally about the size of a smoke detector if you put propellers on it. And so size-wise, that's something to think about. So just to go over a quick example of some research that's going on currently with UAVs. This is actually a poster that I presented recently at the American Geophysical Union. What we're trying to do is we're trying to improve the use of UAVs for sampling the atmosphere and looking at atmospheric pollutants and air quality issues. This is a sampler that's being developed by my advisor, Kathy Cahill. You can see in the bottom right there, the smaller version of it is about the size of a coffee mug. Size constraints are very important for doing any sort of science on UAVs because, as you could see with the Raven, the entirety of where it stores its payload is just in the nose cone. And that's a relatively small space, and it can actually only hold about 1 pound total. And so the lighter that is and the smaller it is, the better it is. Now that instrument would of course go into a different type of drone than the Raven, but all the same. That's in the bottom right there. You can ignore the upper left image. In the bottom right, that's that instrument integrated into the payload bay of a Scan Eagle aircraft. So that's just a bigger one, similar in principle, but larger than the Raven. And this is an instrument for measuring atmospheric particles that some of our team members are actually currently flying right now down near Anchorage for an experiment. This one is not one that we developed. It's actually done with some collaborators, but we're doing a lot of the field testing and campaign trials for it. And those are some of the drawings of us redesigning it so that we can fit it onto a rotor-based UAV so that we can hover it and move it around, similar to how those lampshades are moving. And this is a poster I presented recently, just kind of a quick throw together for the Alaska Fire Science Consortium. Our goal here was actually to see what their needs were and how we could use unmanned aircraft to aid firefighters in responding to wildfires here in Alaska. Those are images from Landsat. It's an Earth-observing satellite, but what you see is the Funny River fire that burned in the Kenai Peninsula down near Anchorage. And we actually, or the team that I work with actually, flew some unmanned aircraft down there to take a look at that fire. And these are some of our results in a GIS, in a geographic information system. What you can see is the red is the fire line, and the individual lines are the flight path of the unmanned aircraft that we flew. And that's just another image of the flight path using Google Earth as the backdrop. And we have it there so that we can actually call up the imagery in the system here. The goal is to see how we could maybe do some sort of a response network or come up with some sort of product that might be useful to firefighters while the blaze is being fought. There's also a thing called hotspot detection, where we try to determine which are the hottest parts of the fire so that fire crews can predict which way it's going to act and where to target their efforts. And these are the hotspots that we detected put over a Google Maps map. And personally, whenever I present any type of research, I like to present the biggest failure of that research, and that was some of our data quality issues. Mostly we just needed a better infrared camera for the unmanned aircraft than the one that we used. And so we had some noise issues, and in some cases it was hard to locate the hotspots. The infrared camera looks at heat signatures, and so that's what we see here. There's been a lot of talk about using unmanned aircraft for studying volcanoes, especially volcanic plumes. And any of you who were here a couple of years ago for Peter Webley's Science for Alaska talk actually got to hear a lot about how researchers at UAF are working on modeling and predicting volcanic plumes. Well, this is a recent campaign by NASA Ames Research Center based out of Moffett Field, California. They called the study In Situ Validation and Calibration of Remotely Sensed Volcanic Emissions, Data, and Models. It's a mouthful. But what they did is they flew down to Costa Rica, and they took this unmanned aircraft called the AeroVironment Dragon Eye, actually made by the same company who make the Raven, and pretty similar in principle. You could see there how it's hand-launched, just like the Raven, and it has a slightly shorter wingspan, but is essentially the same aircraft to a good approximation. And so what they did is they actually set up a base camp near this erupting volcano, near this active volcano, and they launched these unmanned aircraft and then flew them in a flight path so that they would be able to collect volcanic ash particles. And they collected these particles, and the goal is to better characterize what comes out of a volcanic plume, what sort of ash is spit into the air, and how it changes as it expands. And obviously, that's not Alaska. Okay, so now, those are a few things that are going on currently. Those are a few efforts that are underway, and there are a lot of efforts by other research groups also to use unmanned aircraft for fighting wildfires. But I didn't find anything compelling enough that I want to talk to you about today. So now I want to talk to you about the future. I want to talk to you about what unmanned aircraft are going to become, not what they are right now. So as we delve into this slide, I have to ask you to temporarily suspend some of your scientific criticism. Normally in this lecture we want to encourage a very critical eye, but we are thinking about the far-off future. We're trying to imagine, we're people in the 1960s trying to imagine that the smartphone exists by hinting at what people are looking at now for unmanned aircraft. So I want you to embrace your inner Fox Mulder, and I want you to try to believe. And here we go. There's a company actually right now that just started up in Silicon Valley called Matternet. Their idea is to use unmanned aircraft to deliver medicine to villages that may not have road access. So it turns out that right now, a full billion people, 1 billion out of our, I think we're up to, 9 billion people on the planet? A full billion people do not have road access year-round. And so people who may need medicine actually cannot get it most of the year. Now, a lot of this is in Africa, where you have washed out roads for large parts of the year in the wet seasons. But this also happens a lot in Alaska, where remote villages depend on ice bridges to be able to connect to the rest of the world. To get out of their village, they need to cross an ice bridge. And in a winter like this one, where it didn't get cold for quite a while, people may find themselves stranded and relying on expensive air transport to get things that they need, like medicine. So The people at Matternet came up with this idea of putting together a network of drones where they have these stations. You can zoom in on this here. Where they have these stations and uniform drones that are pre-programmed to land in these locations. And you can actually see how a person could come up, and what happens is as the drone lands, completely autonomously, it can change its battery pack so it continues traveling, and it can drop off its payload of medicine, food, whatever it may be. It can only hold a few pounds, so it's not going to be a lot, and you have to choose carefully. But the cost on this came out extremely low. Now, this is their first test flight doing a package delivery with an unmanned aircraft. And there's another application here that I was thinking about that they haven't expressly talked about, but I thought would be a good use for these. One issue that comes up a lot is there is a strong need for radioactive isotopes for medical procedures. But a lot of, I should probably qualify this a bit, during my undergrad at UC Davis that Bob McCoy mentioned, I actually worked at a nuclear reactor, at a research reactor. What we did is we had another number of projects that went on, but one of our projects is radiochemistry to produce radioisotopes that are needed in medical procedures. So we would generate these and then deliver them to hospitals. And there are various reasons for this, to track how blood moves throughout your body, to see how well an organ is functioning, to see whether there are cardiac issues. There are a number of reasons that you'll want to put radioisotopes into a person's body for medical procedures, but all of the radioisotopes that are used for these procedures are artificially created. And so we need nuclear reactors that are actually producing these. But in places like, not places like Africa, but big crowded cities like the one on the right here, traffic is an issue, and the number of reactors that are actually still in operation, especially research reactors, are becoming fewer and fewer. And so what you have is you have hospitals need these radioisotopes, but there's no way to transport them and get them there in time. Because one of the fundamental things about radioactive material is the fact that it's emitting energy means that it's decaying down. It's turning into a different isotope. It's turning into something that no longer emits energy. And so the ones that you need for medical procedures actually only have, you've heard the term half-life, they only have a specific half-life that is not always enough to actually get it to the hospital if the hospital happens to be far enough away from a production center. If you had a drone that didn't have to deal with traffic, that could fly a small and very well-protected case of these radioisotopes to the hospital in 20 minutes, that would make a big difference, and you also wouldn't have to produce as much. And so that's one application that actually occurred to me when I heard about this company, Matternet. And I think what they're doing is pretty revolutionary for that reason. And they've had similar ideas about delivering packages in crowded cities. The reason is because about 500 million people live in megacities, and several billion people live in cities as a whole. Now, we don't have this problem in Alaska, but as you know, in megacities, there are plenty of roads, and you can't go anywhere, right? It's really hard to get to where you're going. And so they were envisioning this idea of implementing these same UAVs, very uniform, lots of landing spaces, to have their own path, their own transportation grid above street traffic but below traditional air traffic, so that you could deliver packages, you could deliver medical supplies, and maybe deliver radioisotopes that are needed for medical procedures. Thought I had another slide there, but apparently not. So another thing that I see as maybe being a future application of unmanned aircraft is autonomous routine data collection. What that means is right now, I like to kind of give this idea by example. Right now we have a number of Earth-observing satellites that are imaging the entire planet as much as twice a day. And these images are used by scientists to look at global climate, to do change detection, to assess the melting of glaciers, to assess the health of the environment. But because they're in space, the resolution isn't as good as it could be, and we're not able to detect as much as we would need. Well, generally in science, when unmanned aircraft are used in science, it's a lot like the NASA case that I showed you. They ship a bunch of people and unmanned aircraft up to some volcano, they hand launch them, and then they begin collecting some sort of data. Or something like this right here, where you have a person with a camera who's individually doing his ecological study. He's imaging plants, he's trying to figure out what's going on in person. Well, wouldn't it be great if instead of having to rely on low-resolution satellite data or having to fly people to a specific volcano, we could have pre-programmed unmanned aircraft, pre-programmed drones that can image an area and produce data for scientific use. Say there's a ice field that we routinely want to look at, we could have drones set to routinely go and look at it without humans having to intervene. Say we want to look at a particular area, say Alaska, to determine whether or not there are wildfires going on. I mean, one of the problems that we have in Alaska, particularly with wildfires, is that there is so much empty space, so much area, that we actually don't necessarily know if there's a wildfire going on until it's pretty far underway. We could hypothetically have unmanned aircraft routinely surveying to see if there's anything that sets off alarms. And there's an image of sort of an illustration of that. You'd have the high-resolution imaging by the unmanned aircraft close to the ground, and then also you'd have the lower resolution but more frequent imaging by Earth-observing satellites. And so the two data sets could complement one another and be used for scientific applications. And then you can stack the data sets together and use them to learn more about the environment, about how environmental change is taking place. And there's actually a recent exploration by a number of NASA scientists to, what they did is they came up with an algorithm where one of their satellites, called MODIS, it has a routine to try to detect whether or not a wildfire is going on. What they did is they took that, and even though it's very low resolution, they made it so that if it thinks it detected a wildfire, if it thinks it detected something anomalous, then what it'll do is it'll automatically call up one of the other Earth-observing satellites that has better resolution and take a closer look at that area to see what's going on. Now, it's easy to envision, instead of calling up another satellite to take this look, to investigate this wildfire, it could automatically launch an unmanned aircraft from a local station to investigate, to see the extent of the fire and see if property is at risk. In a similar thing, the image on the right here is a test bed that's currently going underway where NASA's using one of their drones to routinely photograph a forest that is heavily prone to wildfires. And so they want to see if these can be used with very limited human intervention, right? I mean, the issue here is always to limit the number of people that we have to have staring at computer screens and constantly monitoring that, because that drives up costs and that doesn't work very well in practice. And so they're doing routine imaging with an unmanned aircraft to see if we can better fight wildfires like that. So if there's really one key message I want to leave you with here, it's that we don't actually know what unmanned aircraft are going to become in the future. We have some things that we're doing with them. We have research efforts that are underway. We have things that we've been exploring. But even the future column, the part where I talked about what startup companies are doing with drones, what innovative things people are trying to do, these are very limited. Because if you think about that telephone timeline that I showed, even then, they could not predict what was going to become of that technology. And so one thing that I'm excited to see as a researcher, as a graduate student, is what actually becomes of these. Because personally, I think that these are still in their infancy. And when they do enter the smartphone phase of drones, when they become smart drones, when they become something different than what they are right now, I think that they'll change our lives in very beneficial ways. Thank you.